Find the arc cosine of the square root of 2 over 2. So that's the cosine inverse we're looking for. Okay, what is it exactly we're searching for? We seek real number y on the closed interval of 0 to pi, such that the cosine of y is equal to the square root of 2 over 2. Okay, square root of 2 over 2 is positive. It's positive. Okay, so let's draw a picture of the restriction for y. It has to live between 0 and pi. So here's 0 and here's pi. So that means it's either quadrant 1 or quadrant 2. But we want the cosine to be the positive square root of 3 over 2. So where do you suppose that happens? Does that happen in quadrant 1 or quadrant 2? Well, in quadrant 1, all students take calculus. All the trig functions are positive. In quadrant 2, only sine and cosecant are positive. So we want cosine positive, which means we have to have this guy living in quadrant 1. Okay, now those numbers look familiar. Square root of 2 and 2. It reminds me of the 45, 45, 90 triangle. Pi over 4, pi over 4, pi over 2. 1, 1, square root of 3. Now, in that picture, we see that the cosine, which is adjacent over hypotenuse, of pi over 4 is 1 over the square root of 2. And if you rationalize the denominator, guess what you get? Square root of 2 over 2, exactly what we're looking for. And since this dude that we're interested in, pi over 4, happens to live in quadrant 1, it's a value between 0 and pi. It lives in quadrant 1. It's actually in quadrant 1, not even all the way to pi. It lives in quadrant 1. We know that the cosine is positive in quadrant 1. So we have our answer. Let's write it out formally. The arc cosine of the square root of 2 over 2 is equal to our value, pi over 4.